This is Joseph Alexander Van Zandt. Today I am demonstrating a program that solves an exponential equation in the form coefficient raised to a power plus exponential equals coefficient. In this example, it's the general form 2 raised to the x plus x equals 130. The equation I'm solving today is 7 raised to the x plus x equals 700. This is an input-output computer program that can solve any equation of this form, again, coefficient raised to a power plus power equals coefficient. In my opinion, certainly, mathematics in a very general way is something that people can do, but they usually do it wrong if you actually check calculations. In terms of mathematics, there is a somewhat well-known example. If you take 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, and you add them, you get 55. Now, when most people do that, they get the wrong answer. And those are 10 addition. You're doing addition. You're adding, counting numbers from 1 to 10. You are adding those numbers, and most of the time, people get the wrong answers. Addition is the easiest type of mathematics. If you're talking about, calculus or trigonometry, algebra, and actually getting an answer, most of the times the answer is wrong. In that general way, there's an attempt in engineering, science, medicine, mechanics, aerospace engineering, lasers, to put to have the computer programs do mathematics. This type of program, this type of answer will be difficult. I believe you could try to do it with logarithms, but logarithms, it doesn't always give the right answer. Sometimes you get the right answer, sometimes you get the wrong. But in the answer that I gave, just in terms of addition, a lot of times people come up with wrong answers. I will proceed and show you how this works. Minimum value. I worked this out before. So 7 raised to 1 is 7. 7 raised to 2 is 49. 7 raised to 3, that is to say 7 to the third power, 7 times 7 times 7 is 343. 7 to the fourth power, 7 times 7 times 7 times 7 is 2401, 2,401. So in other words, it equals 700. So it's between 3 and 4. It's between 3 and 4 because 7 times 7 times 7, 7 raised to 3 is 343. 7 raised to 4, 2401 that's 7 raised to 4. So the answer is between 3 and 4. 3 is the minimum, the maximum is 4. Increments, I will use 0, 0, 0, 0, 1. 0.0001 equals. It equals 700. Exponential is raised to 7. The coefficient is 7, and it's x. Okay, so what the program is doing basically is this. It's, as I previously stated, the equation, the computer program which I wrote is attempting to solve the exponential equation. 7 raised to the power of x, or 7 raised to some power, x is a variable, it's not known, plus x equals 700. And what x equals. So what it's doing is it's starting with 3. 7 times 7 times 7 is 343, as I previously mentioned. And 7 times 7 times 7 times 7 which is 7 raised to the 4th, is 241. So it equals 700. So it's somewhere between 343 and 2401. So it's between 3 and 4. My understanding is this type of equation can be used to solve problems in mechanical engineering in general. Brakes, particularly car brakes or aircraft brakes, particularly, aircraft have brakes. If you're on a plane, the plane, if you take into account the ground effect, may be traveling 1,700 miles per hour. It may be traveling 2,000 miles per hour, and it has to stop in 10,000 feet. In the 1950s or so, my understanding is the F-86 Sabre was one of the first jet aircraft. Before that, you had propelled aircraft. Jet aircraft come in at extremely high speed, so you have to have pumping brakes. I mean, the brakes have to go on and off a certain number of times per second. If it does that, then the plane can stop in the length of the runway. My understanding is this type of equation can be used in how many times the brakes have to pump on and off to stop in the length of the runway. Today, in 2025, automotive people, automotive engineers, or people with world-class cars are attempting to adapt this type of technology to normal cars, so world-class cars, so that if it snows, if it's snowing and the car would normally skid, if it pumps, it doesn't skid, and you would not hit another car. For example, if you're traveling on the FDR in Manhattan, okay, and it's snowing, there's ice in the snow, and you just put on the brake and it doesn't pump, you might hit the car in front of you because there's ice and the car skids. Pumping brakes that turn on and off, you wouldn't skid. The car would just stop. But that type of technology is based on mathematics. A computer program has to tell what pumping action has to happen, how many times you have to turn, pump on and off to stop the car in the distance. In reality, there might be a measuring laser. A laser might measure the distance. If it's 50 feet in front of you, maybe you have a 10-foot safety margin. So the car has to stop in 50 feet. So it might have to pump 5 times a second or 10 times a second. But to do that, you have to have some type of calculations. A lot of times, that's one practical application of this equation. The computer program is still doing the calculations here. What it's doing basically, it's starting at 3, and it's increasing it by 0.0001. It's doing that until it gets the right answer. I put that in with input at the beginning of the demonstration. What the computer program is basically doing is it's starting at 3, and it's adding 0.001, and then it's doing the calculations. It's starting at 3, and then it's taking 7 raised to 3 plus 0.001 plus 0.001, and it's seeing if it gets 700. If it doesn't, it adds another 0.001 and it does the calculation again until it gets the right answer. This is, in terms of a computer program, it's called a for next loop. It's going to do that many times until it gets the right answer. It never, in terms of mathematics, you never get exactly 700. You get something very close to 700. Okay, so it finished its calculations. What the computer came up with is this. If you read it, it says the total value of x is 3.36411, meaning that if you take 7 and you raise it to 3.6411 plus 3.6411, you get 700. And if you do that, you get, and you see it here in the final answer, you get you see it at the bottom. In other words, if you do that, you get 699.995063. Originally speaking, you wanted 700. You didn't get 700, but you got something very close to 700. You got 699.995063. But let's confirm to see if that's true. I have here calculator I'll use, and let me see. So if you take 7 and you raise it to the power of 3.36411, which is what the computer program came up, and then you add plus 3.6411, you get 699.995063, which is what the computer program said. So you get an answer approximately 700, very close to 700. This is Joseph Alexander Van Zandt. Thank you for watching.